Yep, it's filming.
Welcome to our week 11 workshop video. Our three members here who are here today are David, Sean and Winbin. Our question was, use the first degree Maclaurin polynomial for cos 2x to find an approximate solution to the equation cos 2x equals 2 minus at. Give your answer to 4 decimal places. So what we're trying to do is here is to find a value for t which will satisfy the equation, an approximate value. So we're going to come in with the Maclaurin polynomial for cos x, and we found that to be this value right here, and I'll pass on to Winbin to show you how he got that.
Okay. First, we need to using the formula, like this formula, and when we using the Maclaurin polynomial, we need to let the a to 0, and then we set up fx equal to cosine x first, and then we differentiate like to first differentiate, the second like third, and then we get the value 1 0 minus 1 0, and then we need to find the pm x equal to like what we write here, and then we will find the find is equal to this formula. Then we using the first 4 term to approximately to 1 minus x squared divided by 2. Then Sam will explain.
Thank you. Okay, so as been explained, this is how we generated this formula here, and then as he also explained, so what we've got here, when we've plotted those formulas from the derivatives, we'll get a value of that comes out to equal 1, that equals 0, that equals x, that equals 0. Next one would equal x squared on 2. So what we do is we get rid of all the ones that equal 0 because they aren't part of the series. And then to take the question asks for us to use the first order p-value, which comes out, so there's p0, which is this value, and p1, which is this value, which comes from this formula here. So what we've done, we've put both of those in. We generate the equation x squared on 2, which we can simplify down to 1 minus 2t squared. Oh, sorry, actually, let me rewind. So what we then do is go from our original question, which was the cos 2t. We, because this is all in terms of cos x, so what we do is we let cos 2t equal this value we've arrived at. So we then have cos 2t equals 1 minus 2t squared over 2, which then becomes 1 minus 2t squared. So then we've got cos 2t equals 1 minus 2t squared. And then from the original question, where cos 2t also equals 2 minus 8t, we then bring the 2 minus 8t down here. So then we have 1 minus 2t squared equals 2 minus 8t. We can rearrange that formula to become 2t squared minus 8t plus 1 equals 0. Then we simply use the quadratic formula, put all the values in, so that's our a value, b value, c value. So as you can see here, quadratic formula, we've just placed it in there. We arrive at 2 t values. Of course, we get the t1 equals 3.8708 and t2 equals 0.1292. Now because the question, the Maclaurin series, is making an estimate around the 0 point, we discount the first one because it's too high above 0, it's an inaccurate estimate. But the second one, because it's 0.1292, that's close to 0, that's an accurate estimate, so therefore our t is equal to 0.1292 as it's closer to 0. And so that's the estimate for the original formula for t.